Assalamualaikum warahmatullahi wabarakatuh and a very good evening to Dr. Nur Rashid and my fellow mates. My name is Muhammad bin Awaludin and I'm from Group F, and today we will present regarding our vehicle dynamics assignments, that is steer by wire. Alright, so first thing first, what is steer by wire? So, unlike the conventional steering, which is the mechanical components connect the steering and the wheels, this system is where the steering wheel sends instructions to an electronic control unit, and the control unit activates an electric motor that controls the steering angle of the wheels. So basically, it is controlled by the electric motor. So I will further my presentations regarding the paper that I have been reviewed, which is the adaptive global fast sliding mode control for steer-by-wire system road vehicles. And for the literature summary, there are three main methodology here, which is being used for this research. So first, to establish the cooperative adaptive sliding mode observer, and second, based on the best set of estimated dynamics by conducting three maneuvering tests, and also the simulation and comparative study with the other control techniques. And for the result itself, we will study about the vehicle states and current stiffness coefficients, estimated SPW system parameter, and sliding gain with AGF SMC scheme, and also of course the control performance between the AGF SMC, ASMC, and also ATSMC. So next, for this discussion, okay, so the additive features of cooperative ASMO and Kalman filter show strong robustness in all three tests, the maneuvering test, which is it's also estimated the sufficient dynamics for torque capability, and the proposed AGF SMC is proven to attain a smaller peak tracking error and a faster convergence in comparison with the ASMC and ATSMC, and of course the discontinuous projection mapping along, if designed, also effectively managed to restrict the estimation drift problem. And for the conclusion, the estimated dynamics based AGF SMC is designed to adapt the unknown SPW system parameters, which is at the same time to eliminate the effect of tie rod disturbance forces, and the proposed adaptive global fast sliding mode control AGF SMC guarantees the precise tracking of front wheels and ensures the asymptotic convergence of tracking error. So that's all from me. Thank you.
Assalamualaikum and good day. My name is Hilmi bin Zainudin, and I will continue this presentation to share about my finding about an article on fault tolerance in steer-by-wire system. So this article is created by science and engineering student from Northeastern University, China, and the article was created in the year 2019. Firstly, I will share about the methodology that they used for their finding. So firstly, they study the existing component fault and error in the steer-by-wire system. This include actuator faults, sensor faults, microcontroller faults, communication error, and fault tolerance requirement. Next, they review the fault detection and isolation on steer-by-wire by approaching these two fundamentals, which are hardware redundancy and analytical redundancy. Hardware redundancy is about add one or more modules to a specific module, usually in parallel, so that the duplicated output signals can be compared, leading to fault diagnostic decision. This includes steering motor, feedback actuator, sensor, ECU, and communication protocols. While analytical redundancy is to reduce the number of redundant components without compromising reliability to steer-by-wire system. And lastly, they investigate different fault tolerant controls, FTCS, and make a comparison to provide overall development in fault tolerance of steer-by-wire system. Now, I will share with you about the result they have obtained. The article describes that the best solution is by applying fault-tolerant in-steer-by-wire system (FTCS) configurable controller. This method is divided into two groups, that is online configuration and projection-based FTC. The reason of applying this method is because FTCS algorithm can detect the fault, recognize it, and adapt to the fault. The controller configuration includes switching, adaptive control, control reallocation method, two-way control, steering control, robust control, and structural control. So next we can move on to the discussion of this article. There are three discussions. Firstly is the model uncertainty. FTCS design for steer-by-wire system relies heavily on the fault information provided by the FDI scheme. The problem is that the FDI scheme is built on the assumption to the mathematical model, so there will be increase in fault detection even though it is necessary. To remove the interference of false alarm detection, a robust FDI needed to be studied in depth and applied to this system, so it can provide rapid and reliable detection of system fault with respect to the modeling errors. And next is about the time delay. Increase in communication delay can decline the reliability of the steer-by-wire system. If the delay exceeds the maximum tolerable response time, the security of the vehicle can no longer be guaranteed anymore. So the solution is to increase the integrity of the steer-by-wire system. The interval between the fault occurrence and the initiation of the fault-tolerant controller needs to be decreased. And next, we can talk about the human inappropriate behavior. So road danger is a man-made crisis. This is because human error accounting for 90% of the road accident. Driver faults include unavoidable situation which the human cannot react quickly enough, drowsiness caused by excessive driving periods, limited steering skill, and falling asleep. Therefore, the issue need to have an ability to identify the type of human fault, and fault-tolerant control scheme should be designed to adapt the driver's fault and achieve an optimal driving performance. And lastly, we can conclude that steer-by-wire system is a safety-critical system which has a high demand on safety performance, fault-tolerant capability, and also cost. Many different properties of the fault-tolerant controls for steer-by-wire system have been reviewed and examined. One of the particular options for the moment is applying the FTCS algorithm configurable controller. Nevertheless, there are still a lot of design difficulties needed to be improved, and further work needed to be done in this area. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day. My name is Ahmad Syakir Hakimi bin Basri, and I will continue with my parts of literature review on synchronization of stability control of dual motor intelligent steer-by-wire vehicle. So this is the literature review. What I can say for the methodology, the models of dual motor steer-by-wire system and the vehicle are established. Next, considering the interference of the lateral wind sensor noise and the limitation of control output. Next, a sliding mode speed synchronization control strategy. Last but not least, the simulation of carried out by using car sim simulink and the hardwired the loops experiment in conducted based on the dual motor steer-by-wire experimental station. For the result, the safety of the steer-by-wire system improved. Next, enhance the fault tolerance and reliability of the system. Next, improve the stability and tracking performance of the vehicle. Next, enhance the synchronization performance between dual motor. Last but not least, the effectiveness and good control performance of proposed control strategy. For the discussion, in order to improve the safety by wire system, a dual motor system is proposed to enhance the fault tolerance and reliability of the system. The dual motor system by wire vehicle often loses its stability due to external interference, and the synchronous response between the dual motor will further deteriorate the stability of the vehicle. In order to verify the effectiveness of the proposed control strategy in practical application, a hardware in the loop experiment is conducted on the dual motor shift-by-wire experimental station. Last but not least, the shift-by-wire system can effectively improve the steering characteristic of the vehicle and improve the handling stability and comfort. But The reliability and safety of the electronic connection system is a major concern. For the conclusion, a dual-motor shift-by-wire system is proposed to enhance the fault tolerance and reliability of the system. Then, aiming at the problem that the stability of dual-motor shift-by-wire vehicle is often disturbed by external interference and response between dual motor is not synchronized. Next, in the upper layer, considering the influence of the lateral wind, sensor noise, and limitation of the control output and vehicle performance and yaw rate controller. Next, in the lower layer, a synchronization control strategy based on cross-coupling control structure and sliding port control algorithm is proposed, and a sliding mode speed synchronization controller is designed. Last but not least, the combined simulation analysis and hardwire in the loop experiment are carried out by CarSim and Simulink and dual motor shift-by-wire experiment station respectively. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairulnaim Pauzi. Today I'm going to present my paper review assignment with the title Adaptive Sliding Map Control of Track Position Tracking System for Steer-by-Wire Vehicle. This is my literature review. The methodology 1 is only deal with the tracking control algorithm using one actuator. Secondly, using ASMC algorithm is that it does not require an estimation of the cornering stiffness coefficient value. Thirdly, change the stiffness coefficient parameter in various road conditions using the parameter adaptation law. For the result, adaptation sliding mode control algorithm can effectively compensate for the rate force acting as disturbance. Secondly, the tracking performance at zero vehicle speed is improved by use of the proposed stiffness model. Lastly, control performance of adaptive similar sliding mode control. For the discussion, a dynamic modeling of a steer-by-wire has been studied and adaptive sliding mode control algorithm has been proposed to cope with various road surface conditions. ASMC algorithm replaces the lateral tire force with a stiffness and change the value of the stiffness coefficient according to the road surface condition through the adaptation law. A dynamic stiffness model was introduced in the proposed algorithm to improve rack position tracking performance in a zero vehicle speed scenario. In a dynamic stiffness model, the stiffness center is not fixed, but changes depending on the actual rack position. For the conclusion, we can say the tracking performance at zero vehicle speed is improved by use of proposed stiffness model. Secondly, adaptation sliding mode control algorithm can effectively compensate for the rack force acting as a disturbance. Also, proposed algorithm ensure the tracking performance in great road condition without using any road surface information. Lastly, more research is needed to develop scheme that integrate system to achieve high level performance objective. These are my reference. That's all from me. Thanks.
Sing! Sing! Sing!